And let's go. So, completing the square, you'll need to understand this formula because essentially it's really just going backwards from a perfect square. Hence why it's called completing the square. Let's remind ourselves, what is the formula when you're expanding a plus b squared again? Let's go with Sion. What's the formula?
A squared plus 2ab plus b squared.
Beautiful. So this is the formula that I wanted all students to know, not the distributive law. You had to remember that quickly. So let's do the pattern then. Let's pick a few students. Let's go, Luke, can you expand this quickly? Tell me what the expansion should be. X squared plus 6x plus 9 is correct. Well done. Let's go with Numafi. Next one.
X squared minus 8x.
Beautiful. Let's go with Lillian. Last one over here. Whoops. So you're right. Plus 10x plus 25. For those who are still questioning about it, we're just simply following the rule. Square the first term, double, so 3 times x and then double it, or negative 4 times x, double it, 5 times x, double it. That's where we get the middle term. And then square the last numbers. So square of 3 gives you 9, square of negative 4 gives you 16, square of 5 gives you 25. So that's the speed that you should be able to do from exercise 3A. So when you're doing the worksheet, that's what I was looking for. Now, completing the square is going backwards. You're taking a general quadratic equation with 3 terms, so x squared, there's one with an x squared, one with an x, and then no x's. You're taking 3 terms and you're trying to factorize it into 1. See, all of these brackets, what's nice about it is that you only have one x. So one of the problems when we're solving problems or equations is from year 7 to 8, it's always been nice when there's only one x. So I can give you, in year 7, it'll be something like this. That's what you're learning. And then you have to learn inverse operations to solve. Back in primary school, instead of x, it was magic square. But you were doing algebra the whole time, right? You were really just trying to figure out, what would I put here to make this statement true? Then as you go through year 8 and year 9, we start increasing that. We might do x on 4 plus 3, so it becomes a little bit more linear equations, but still only one x. Then towards the end of year 9, this is when we start to introduce the idea, well, what if I had x squared equals 9? You still could do it because it's still just one x, but then once we introduced that becomes a problem. Okay, so that's where it's tricky. It's when we have 2 x's. All of these have 2 x's, which we don't like. Completing the square is a technique that allows you, if cross method doesn't work, or any other method you can use, like difference of perfect squares, all of those don't work, then you test out with completing the square. And the idea is to bring it back to one bracket, because once you have one x, it's easier to solve. Okay, that's the goal. So how do we do this then? Well, there is a pattern. There's a pattern that you went through to move from left to right. But going backwards now, we know, one thing we know is, well, to get this first one, the first number in the bracket has to be what? How do I get x squared? X, because I had to square the first one. All of it had to be x, and it's one of the limitations of completing the square technique, that the number in front of x squared has to be 1. Okay, not a negative 1, not a 2. It has to be a 1. And you'll find that as you're doing the first few questions, they're all 1s, and then later on, they'll have a 2, they'll have a negative. Your job is to get rid of that and just get that 1, okay? Because it only works when it's a 1. That's the pattern, yeah? So we know that all has to be an x. Then you say, well, to get 6x, I had to do something times x and then double it. So if you think about it, something times x and then you double it, well, you can go backwards. Instead of doubling, let's halve it. What's half of 6? 3. So that means 3 times x, which is 3x, and then double it, well, it gives you 6x. So hence, this number has to be positive 3. But that's how they would have taught you last year. Some of your teachers would have said the technique is step 1, find the b term, half the b term. And then you just follow it as an algorithm, but you don't, if you really realize it, you're just going backwards on what you were doing. Instead of doubling it to get here, well, you're halving it to get back here. So look for the b term is what the teachers usually say, because that plus 6, where'd you get the plus 6 from? It's because you had to double 3 times the x. So double 3, so half of 6 gives you the 3, so now I know that's a positive 3. But if that's a positive 3, then I definitely know what the last number is. Because if that's a positive 3, then this has to be 3 squared, which gives you 9. Just like this, 5 squared gives you 25. Negative 4 squared gives you 16. And positive 3 squared again gives you 9. Make sense? Okay, so the key part is, as long as you know the first 2 terms in the brackets, you know what the last number is. And that's what completing the square means. So here, I'll give you an example to work backwards now. There's a last number that I need to know. To know that, I need to fill out these 2 brackets over here. So, what's the first term? What does it have to be? X. Very good, because we know that this is an x squared, so clearly that has to be an x. And same thing with the next one. This one's x squared, so this has to be an x as well. I'm just missing the number. What's the number? Well, to get a positive 4, the number inside the brackets must be what, Anthony? 2. Very good. It has to be a positive 2, because 2 times x is 2x, but then double it and give me 4x. So yes, it's positive 2. What about this bracket here? If that's negative 12x, what should the number be? Let's go with Zoe. Minus 6. Very good. It had to be a negative. Oops, I'll just change that color so it's consistent. It had to be a minus 6 because negative 6 times x is negative 6x, and then double it will make that negative 12. Now, once you know that number, then you should know the last number for each of these equations. What should the last number be there, Ben? For the first one up here. Yep, what would it be? Very good. It's 4. And the other one, let's go with Lucky. 36. So what you're able to do there, that is the skill. That's all you need to know. Okay, that's all you need to understand on the logic of what completing the square is. And now I'll explain why last year, if your teachers taught it this way, they would have said half the b term to get here, and then plus or minus the square, right? And a lot of kids just follow the algorithm, but they're not thinking, well, why is that true? I'll show you. Let's have a look at this as an example. See how you got x squared minus 12x? If I asked the same question, I said, well, we hate the fact that you have 2 x's. It's hard to solve. So what we do is we say, all right, it's easier if we can factorize it into something squared. Now do exactly the same things I just showed you before. What would the 2 terms have to be inside the brackets? What would it be? Let's go see on. It has to be an x because that's an x squared and that's a negative 12. So this has to be a minus 6. But if that's a minus 6, what would the last term have to be? 36, just like what you did before, right here. X minus 6 squared, you told me it should be x squared minus 12x, and it should be a plus 36. Do I have a plus 36? No, I've got a plus 40. So what's happening here is we're saying this. We're saying I currently have x squared minus 12x, and I've got this plus 40, but what I wished I had was I wish I had a plus 36. Because if I had a plus 36, it would be this. That would be a perfect square. This is what we call a perfect square. Because that's essentially saying, if I drew a perfect square, it'd be x minus 6 by x minus 6. And the area that you get is exactly x squared minus 12x plus 36. That's what the area is. That's why we call it a perfect square. But with a plus 40, it's not a perfect square now. It's a problem. That plus 40 is what I don't want. But I love the 36. So what do we do? We say, well, let's add a 36 in. Let's just write plus 36 because that's what I want. But if you write plus 36, you've changed the equation. So if I don't want to change the equation, undo it. This is why we say add on the square and subtract the square. Because if you add on 36 and minus 36, now if I ask you to simplify this expression, it's still exactly the same. It's no difference. But why do we add on and then subtract? Is because this right here, we already know that's a perfect square of x minus 6. That's what this is. And then negative 36 plus 40, we can simplify. Negative 36 plus 40 gives me plus 4. This is what we call completing the square, where you turned a general equation to what I taught you last session, turning point form. So now with the turning point form, you can read it. Let's revise your memory now. If we were to just look at this equation right here, so we started off with, I'm going to zoom out a bit. we started off with x squared minus 12x plus 40. We knew the technique to get here. And remember, all I did was I just said the last number should be a plus 36. Don't have it? Write it in. Subtract it, so technically it wasn't ever there. But negative 36 plus 40 simplifies to plus 4. Now, why do I like this form? Just like what you did in exercise 3D, you can sketch this graph now. You can read where it goes, up, down, left, right, smiley face, frown, whatever it is. But you can also work out axis intercepts by what I showed you last session. I'm going to do it again here. But let's have a look. If this was your equation, hypothetically, and I asked you to sketch it, what's a plus 4 do again? Let's go with Ishan. Do you remember? What's the plus 4 tell us? That is true, which essentially normally I say it means up by 4. But yes, you're right. It means up by 4. Very good. So the plus, remember, that's K. If it's positive, it goes up. If it's negative, it goes down. What else do I know about the graph? Let's look at the number in front of the bracket, which even though they don't write it, it's technically a positive 1 there. What's a positive 1 tell me? Let's go with Adi. So looking at this equation, what's the number in front of the bracket squared mean again? This is from last session. If A is positive, what does it tell us? It is a smiley face, because if you're feeling positive, the shape of the graph should be a smiley face. If it's 1, well, it's a normal shape. Obviously, the larger the number, so I said if it's larger than 1, it'll get thinner. And if it's between 0 and 1, it should be wider. So in this case, it's a normal smiley face. And then the one technique that I said you'll never find anywhere else but me. Any other students who does this, that means they're my student. Okay, so if you find anyone else who ever says, let x minus 6 equal 0, they're 100% Mr. Trans student. Okay, so here we go. This is my other technique I told you. If you want to know if it moves left or right, let x minus 6 equal to 0. Solve for x equals 6. And what does that mean? Let's go with Mete. Yeah, just means it goes to the right by 6. And so if I ask you to roughly sketch this graph right now, even though I know the question doesn't ask that, you can go from this to not knowing much about it to this. Now you can say right by 6, up by 4, smiley face. So if I drew that, right by 6, up by 4, here's my turning point. And that's why Ishan was saying he was correct. Whoops, it's 6, 4. That was the y coordinate of the turning point. Okay? And we said, Artie said it was a smiley face. Here we go. If I drew it. Now looking at that, is there any x-intercepts? There's no point trying to solve it. So there's no point letting y and then trying to solve it, because I already can tell there's not going to be any x-intercepts, but there's definitely a y-intercept. Now, how do you find the y-intercept again? Normally, what do you have to do? Let x equal to 0. Now you have a choice. You've got two equations. You've got the turning point form and you've got the general form. Which one is easier to solve? That one. If I wanted to find the y-intercept, let x equal to 0, these two will cancel out. You see, if I just put in over here, if this was y equals x squared minus 12x plus 40, and to find the y-intercept, you told me let x equal to 0. Well, if this is 0 and that's 0, well, that's going to cancel out. So really, I already know what the y-intercept is just by looking at that equation. This equation is good for the turning point. This equation is beautiful for the y-intercept. X-intercept, well, there's no point. We can already tell there's none. So from here, if I were to sketch this properly, 0, 40, turning point labeled 6, 4, that's 3 marks. That's your next exercise. So next session, we're doing 3F. That's what you're doing. Is that easy? Okay, and that's what I mean with your basics. If you don't train the foundation, if 3AB, you haven't done that, then I couldn't have taught you this. I couldn't have taught you to understand the logic if you weren't able to pick up what I was trying to say here. But once you get that, then I can go backwards and teach you that. Yep.
With that, this is like the turning point. It just finds the x-intercept. When you make y 0, you like put the score where y is, when it becomes negative, doesn't that mean there's no x-intercept?
That's exactly it. So what Anthony just said, and I didn't want to get to this point because I was scared I was going to lose you, but what he raised is such an important point. Right here, what he was saying is if I use the turning point form, y equals to x minus 6 squared plus 4, if we were to find the x-intercept, hypothetically, you didn't picture it, you didn't draw it out, you got up to this step, you're like, yeah, I did complete the square, and now you're trying to find the x-intercept, right? What you would have said is, you would have said, let y equal to 0, and then you would try to solve for x. Now, the way I taught you in the previous session was that I would say the best way to do it is to do inverse operations. So here, plus 4, you minus 4 on both sides. And you know what's interesting? So those who aren't strong with their algebra at this point will do this. It's negative 4 equals to x minus 6 squared. And they will know, how do you get rid of the square again? What do you do? Square root. Square root both sides. And this is where it comes into a problem. What do you think those students would write in the next line? Plus and minus 2. Because I always said when you square root, there's a plus and minus. And they'll square root that and they'll write plus minus 2 and they'll carry on. The problem is that they need to realize right at this step, you cannot square root a negative number. It's impossible. And they did try that on the calculator and they're like, oh, it's impossible, error. So they're like, oh, I'll just make it a positive then. They'll change it to a positive and they'll write plus or minus 2. When it's impossible, it doesn't mean you've done anything wrong. It just means you can't solve it. And there's a reason why you can't solve it, is because the graph, there is no x-intercept. So of course there's no answer. So at this point you were meant to stop. At this point you were meant to realize there was a square of nothing will ever give you a negative number. Just think about that for a moment. Can you square any number right now that will give you a negative number? So for example, if I asked you, think of a number where you square to give me a negative 9. There's no number that you can square times itself that will give you a negative. Okay, and so that's one of the issues that you are meant to stop right as soon as you see that. A lot of students will carry through. And that's the difference between understanding what you're doing and just following an algorithm. Okay, so that's the difference with the algebra part. So I didn't want to confuse you there, but that's a really good point to bring up that I often see at the year 11 level when you get to this point, just realizing you cannot square root a negative number. Hence, it's not possible. And if it's not possible, nothing wrong. You haven't done anything wrong. It just means there's potentially no x-intercepts for that graph. Okay? All right, but today's lesson, you're really just working on practicing completing the square. So each and every one of these problems have 2 x's. 2 x's. We don't like 2 x's. It's too hard to solve. We like it when there's 1. So here we go. We follow the same technique. Let's do it again. I've got x squared plus 6x, and I've got a minus 1. Now my goal is to factorize it into a perfect square. So let's figure it out. What's the first number in the bracket? What should it be? Let's go with, what haven't I chosen yet? Let's go back to Sion. Sion, what should be in the brackets? X plus 3, very good. So we know that square of this number has to give you x squared, and then 6, well, that comes from the result of doubling 3 times x. So half of 6 is 3. Correct. But if that is 3, what's the number at the end that I should have? At the moment, I've got negative 1. What should that last number be, Ben? 9. It's a plus 3, so 3 squared should be a positive 9. That's what I wish I had, because that's a perfect square. But I don't have that. So I'm going to write the 9 because it just gives me visually what I want. And then I say, well, subtract 9 because technically it was never there. But if I do that, this now simplifies down to this bracket. And negative 9 minus 1 gives you minus 10. That is completing the square. Okay? Now, just so that you understand the difference between solving and factorizing, last year the year 10s learned how to complete the square. And it says factorize by completing the square, right? Factorize means you have to put into 2 brackets. This is not factorized yet. This is completing the square, but not factorized. So at this step, because they didn't ask you to solve, usually we bring it across because we can solve it, right? We're saying let y equal to 0. But if you're not solving, what do you do from this step now? How do I factorize this expression? There's one technique that you learned from exercise 3b, or would it be messy? Difference of perfect squares. This is what we were saying, practicing that 2 skills that I gave to you. Expansion of perfect squares, which you just did before, difference of perfect squares is here. Something squared minus, and then 10. So here we go. Let's do it. I'm going to do it slowly so that you're familiar. So you need something squared minus something squared. This is how you're going to use the difference of perfect squares formula. If you've forgotten what the formula is, I'm just going to write on the side for you to remember. It is a squared minus b squared is equal to a plus b, a minus b. So if you can write it in something squared minus something squared, that's your factorized two brackets. Let's have a look. What you got in the first one? You need something squared. So I've got x plus 3 squared there. What should I write in the first bracket there? Who wants to have a go? Hands up. It's good practice, that's why. For DOPS. Muffy? 9. X plus 3 is correct. X plus 3. So what I want you guys to see is you're trying to write this in a form that is something squared first. And already, you notice how it's already x plus 3 squared? That is telling me I can actually just leave it here and just say, that's x plus 3 squared. Because remember, what do I want? I just want something squared. I already got it. I don't need to change it. But this 10, square of what will give me 10? Square of what will give me 10? There is nothing that we know, so there has to be an irrational number. Square root of 10. Okay, so here you would write then square root of 10. Now, if this step here is a bit confusing for all of you, one of the tips I teach my students is when you want to change whatever this term is and that term is into the brackets, just square root both of them. So here, if I zoom in, if you want to know what goes inside the brackets, square root this term, the square root and the square cancels out. What are you left with? X plus 3 goes into the brackets. Over here, if you want to know what goes inside the brackets, well, square root it. I don't know what root of 10 is. So it goes there. It's root of 10. Because if you try squaring it now, square or square root, those two will cancel out and you end up with the 10 that you want anyway. Okay, so I know this one is a bit more confusing, but if I gave you a simpler version of DOPS, this is the one that most students remember. X squared minus 9. If I asked you, square of what will give you x squared minus square of what will give you 9, all of you can answer this one. And the reason why is because it's one term. It makes it look less intimidating. But the technique that you use is exactly the same. So if I said, what goes inside the brackets? Well, you all know it's x. But it's the same idea because all I had to do is I would do square root of x squared. These two cancel out. X goes in the brackets. 9. I know you guys know your squared numbers, but how did you know that was 3? What you would have done, you would have square rooted 9. Square root of 9 gives you 3. That's what you would have wrote. And then you would have followed your DOPS formula and you would have said it's x plus 3 times x minus 3, right? That technique does not change, even when I give you something this crazy. Yeah, same idea. Square root of that gives me x plus 3. Square root of that, well, I don't know. Leave it as root 10. Now that you've got this form, let's write out the brackets. Here's my DOPS. Bracket, bracket, bracket. This is my a. So it becomes x plus 3 plus root 10. And then here's my a again. X plus 3 minus root 10. Can you see how I'm following a plus b? And here is again a minus b. I'm following the same formula that you would have done down here. What's the difference between that example and this example? This one has more numbers in it. But same idea. Okay, exact same idea. You just did square root of that to get here, square root of that to get here, and that's a plus b, a minus b. I'll do the same thing. Square root of that gives you this, square root of that gives me this, and then a plus b, a minus b. That's all I did. Okay, followed exactly the same thing. Have a go with the next one. I'm going to time you guys. I'm going to stop the video for a bit. This one does not have a difference of perfect squares because you actually need a minus. Notice the previous example. When you have a plus, see that plus 4 there? When it's a plus, you can't do something squared plus something squared. It's not a difference of perfect squares formula, so therefore you stop there. There's no x-intercepts for this one. Same thing for this one here. If you do it, you should end up with x squared minus 4x. The plus 7's over here, and what we need is a plus 4 and a minus 4. When you factorize that, that gives you x minus 2 squared, and then this gives you plus 3. The problem is, that's a plus. So if you try to visualize it, up by 3 to the right by 2, so just picture it, to the right by 2, up by 3, it's a smiley shape. You can already see there's no x-intercepts. If there's no x-intercepts, you shouldn't be able to factorize it, because the whole point of factorizing is to solve for the x-axis intercepts. That's what you've been doing in 3C. You have to be able to factorize, then you can solve it, right? So here, if you can factorize it, it means you can solve it. There was no way you could have factorized this, okay? Unless you pretended that was a negative and then you carried on with what I taught you, then yes. Okay, so you're meant to stop here. That's as far as you can go, and then you can start sketching from there. Okay, so the whole point of factorizing is to know, will there be an x-intercept or not? If you can factorize it, it will have it. If you can't factorize it, it doesn't exist. Okay? All right, team, I think I'm going to pause there, and then we can continue our next session. I just want to give you time to practice these so far. These next ones, if you're sort of game enough to have a go, the only difference between this one and the above is that you'll involve fractions. Because half of 5 does not give you a nice whole number like before. Half of 4 is 2, half of 6 is 3. Well, half of 5 is 5 on 2. So you have to work with fractions instead of whole numbers. And this one, you have to factorize the 3 out. Okay, so this one you have to start off by taking out 3. And you've got x squared plus 3x plus 1. So now the number in front of x squared is 1. So that's when you can complete the square of just inside the brackets. So you do exactly what we just did before, but again, this one will end up with a fraction because it's half of 3. So these two, it's not hard per se, it's just practicing your fractions. So those who struggle with fractions at the moment, don't do this one yet. Practice the previous steps. Make sure that you're comfortable making sure that if the b term is an even value, that you can complete the square. That's the skill from 3E. Okay, so exercise 3E is about you completing the square. If you can complete the square, you can sketch the graph. That's how it works. Cool? All right, I'm going to stop the video.